Hi everyone. So today we're doing a real quick lesson on compound interest. So I'd like you to find this page in your notes packet, and it's probably a few pages back. I'm skipping around a little bit. So this is towards the end of the chapter. It's going to be either the last page or the second to last page in your notes packet. And what this is dealing with is compound interest, and I'm talking interest like that you earn at a bank. So you take your money to a bank, you deposit it in a savings account, and they say we're going to pay you such and such interest. That's what I'm talking about here. Okay. This formula here is telling us how to calculate it, but before we get to that, I want to explain for a minute what I mean by compound interest. Okay, I want to make sure that we're clear on what it means to be compound interest. So let's suppose you walk into the bank and you deposit $100. And the bank says, sweet, thanks, we're going to pay you 5% interest. Okay, and we're going to compound it. Now, I'll tell you right now, 5% is pretty generous. But I'm just using some real simple numbers for my example so you can see what is happening here. So that $100 is going to sit there for, let's say, a year. And at that time, the bank is going to calculate your interest. So the bank is going to say, all right, we're going to pay you 5%, which is 0.05, times that $100, and that's going to be $5. So the bank is going to take that $5 in interest and add it to your account. So now you have $105 in your account. Okay? So that $105 is going to sit there. So you've got $100 of your own money, $5 of free money from the bank. And when another year rolls around, the bank is going to calculate interest again. But this time, instead of doing 0.05 times 100, they're going to do 0.05 times 105 because that's how much you now have in your account. So now you're earning interest on that free money. Okay, that free money that the bank gave you. You're earning interest on your original 100 and on your free money. Okay, which means if you multiply this, you actually come out with 525. Okay, which you'll notice is higher than what it was before. Okay, so now you're getting even more free money added to your account. We're going to take that money, tack it onto this, and now we have 110.25 in there. So look at that. Now you have 10.25 just in free money. Okay, you haven't put any extra money in there and your money has already grown. And what's going to happen is it's going to grow faster and faster because the next time we're going to do 0.05 times 110.25. I don't know what that is off the top of my head, but it's going to be bigger than the 525. Okay, it's going to be bigger than that. So as long as I don't take any money out, every time I earn interest, it's going to be a little bit more and a little bit more. And so that's what it means to be compound interest, is you're earning interest on interest. Okay, you're earning interest on free money that the bank has already given you. So they just throw it in with the rest of your money, and then the next time that interest calculation rolls around, you've got more in your account than you did before. Let's talk about how this is calculated. I know this formula looks scary, but it's really not so bad. First thing is, P is your principal. That's your initial investment. Okay, so in my example from before, I initially invested $100, so that's what goes here for P. Okay, and A, that's just going to give me how much is in the account at the end. So this is like your answer. This is the question you're asking is, how much will I have in my account after such and such amount of years at such and such interest rate? This is your answer to that question. Okay, the R represents your interest rate. So in the previous example, mine was 5%. Okay, but remember, you have to convert that to a decimal. You can't put it into the problem as a percentage. And so remember, to convert to a decimal, you're always going to go 2 decimal points to the left. It's always 2, and it's always to the left because a percent is always out of 100. Okay? T is your time. All right, so how many years are you leaving it in there? 5 years, 10 years, 25 years. Okay, so you always want to make sure that measurement is being done in years. This is the one that gets a little bit tricky for people, the number of times we compound per year. So in the example I did, I think I was just doing it once a year. That's what we would call annually. But you can compound twice a year, you can compound 5 times a year, you can compound 12 times a year. So that's what the n represents, is how many times a month you're compounding. I'm sorry, how many times per year you're compounding. I'm going to throw some words at you real quick, and I just realized I did not leave you a space to write these down in your notes, but I would write them down someplace, even if it's just, in the empty space here. So looking at that n number, if it says you're compounding annually, whoops, I guess I need something to write with. Compounding annually means n is going to equal 1, because that's 1 time per year. Semi-annually is like every 6 months or every half a year. So semi-annually, n is going to equal 2, because it's 2 times per year. The next one you'll see is quarterly. That's 4 times a year. Okay. You might see, let's see what would come next. I guess monthly. Well, if you're compounding once a month, that's 12 times a year. This one doesn't come up as often, but you may also see daily. And that's 365 times a year. I think that's all of them that you're going to run into. So when it comes to finding that n number, this is sort of, these words are what's going to show up in the problem, and then you have to make it into a number yourself. Okay? So we'll practice with that, in a few minutes, but you just might want to jot those down someplace. So let's look at a couple of examples here. And I'm going to go ahead and rewrite the formula. And this formula was on that previous slide, so you might not need to recopy it, but just so we have it here in front of us. A equals P times 1 plus R over N to the power of N times T. Whoops, that's a T up at the top. Okay, so first example. $3,000 is invested at 3.2% compounded quarterly. Find the total amount in the account after 5 years. So let's sort out what our letters are here. Here's my initial investment. That's going to be my P. 3.2%, that's my interest rate, so that's R. But remember, to put it into my problem, I need to convert this. I know it looks like a decimal already, but it has a percent on it. So that means I need to take my decimal point and move 2 to the left. So my R is going to equal 0.032. Compounded quarterly. Okay, so that's where my n number comes from. It's always going to come after compounded. It's always going to say compounded annually, compounded semi-annually, compounded quarterly. Okay, quarterly, we said, was n equals 4. And then find the total amount in the account after 5 years. So that's your t value. That's your amount of time. Okay, so that's sort of how I start every one of these, is I just kind of sort out what my different numbers are. And then I'm going to take those values and just plug them into my equation. So I would say A equals P, which is 300, times parentheses 1 plus 0.032 over n, which is 4, to the power of 4. Notice that n comes up twice in your formula, times 5. And for the most part, in your calculator, you can type it in exactly as it's written here. Okay? Don't try to put any extra parentheses or anything like that. You can just type it in exactly as it shows up here. The only exception is if you're using an older graphing calculator, and as you're typing, so I'm going to write underneath kind of what it would look like as you're typing it. You would type in 300 parentheses 1 plus 0.032 divided by 4. Close your parentheses. If when you're typing and you hit the power button, you hit that little caret key, if that symbol actually shows up like that and then it lets you just keep typing down here, this 4 times 5 is going to need to be in parentheses. Either that or you can just multiply it yourself and make it a 20. Okay? The newer graphing calculators, when you get to that point, so this is like the older graphing calculator, the newer ones look like this. 300 times 1 plus 0.032 divided by 4, parentheses. And then when you hit that caret key, which is the button that looks like this, okay, the little arrow pointing upward, instead of actually showing up, it just brings up a little box up here and it lets you type right here. If it does that when you're typing, you don't need to worry about parentheses around the 4 times 5. It doesn't hurt to put them there, but you don't have to do it if your calculator does this for you, if it automatically puts it in the exponent. The problem is, if it's written like this and you just write to the power of 4 times 5 without the parentheses, your calculator acts like the 4 is the power and that everything in the problem then is being multiplied by 5. So you need to tell your calculator that this whole thing belongs up in the power. Okay, I digress. I need to type this in and see what our answer is. I came out with 351, 83. Okay, sorry, that's kind of hard to read, but I ended up with $351.83. So if you haven't typed that into the calculator yourself, I would go ahead and give that a try. Right now, make sure you get that same answer. And then I always encourage you, after you do a problem like this, to make sure your answer makes sense. So we started with $300. So if I had come out with a number that was less than $300, I'd be pretty ticked off at my bank. Okay, because you're not supposed to lose money when you're earning interest. So your answer should come out to be more than what you started with. However, not like a crazy amount more. If you invest $300, don't expect that to turn into $1 million after only 5 years. Okay, so 351 is pretty reasonable from 300. Okay, an extra $50 in interest. But again, it should be reasonable. It should be bigger, but not so big that it's like out of the ordinary. Okay, so let's look at this next question. And I'm going to just slide up a little bit here. So 41,248, that's our principal again. 4.6% compounded semi-annually. So there's my interest rate. And again, I'm going to move my decimal point twice and make that a 0.046. Not very many mistakes come up in these problems. Usually students are pretty good at them, but the mistake I do see is forgetting to move your decimal point on that interest rate. Okay? Compounded semi-annually. Semi-annually is twice a year. Now, 54 months, the thing we have to be careful with here is this is being measured in months, not years. Okay? We want to take that 54 and turn it into years. So there's 12 months in a year, so I'm going to do 54 divided by 12. Gosh, I think that's going to be 4.5. So 54 months is 4.5 years. Okay, so that's my T value. Okay, again, I divided by 12 because there's 12 months in 1 year. So when I go to set up this problem, A equals 41,248. Parentheses 1 plus my interest rate is 0.046 divided by my n value, which is 2, and then I'm raising to the power of 2 times 4.5. Okay, so again, in your calculator, you may want to put that 2 times 4.5 in parentheses, or just make it a 9. 4.5 times 2 is 9. Sometimes it's easier just to do that multiplication on your own. Let me type that in real quick. Okay. Gosh, I ended up with a big number. But I think it still seems reasonable. So I ended up with 50,615. And you can always round to 2 decimal places because this is money. And 51 cents. Okay. Again, bigger than what I started with, but not unreasonably bigger. Okay, one more to throw at you. An account currently has $7,240 in it. The account was opened 6 years ago, and I want to point out that word ago, at 2.3% compounded monthly. How much money was invested initially? So technically in this one, we are looking for the P value. We have the A, and we're looking for the P. But it's a little bit complicated to put in a number for A and solve for P. Not that it's impossible, but I usually tackle this a different way. It's going to sound weird, but I would take this number and treat that as my original investment. So let's pretend I'm walking into the bank and I'm investing $7,240 right now. But then my time, I want to go back in time. I want to say, if I invested this much money today, how much would I have 6 years in the past? Okay? And so to do that, what I'm going to do is make my t value -6. I'm going to go backwards 6 years. Okay? Just like before, my interest rate, I'm going to move the decimal twice, so it's going to be 0.023. And compounded monthly means my end value is going to equal 12. So I'm going to use the formula just like I normally would, except I'm going to have a negative t value. So 7,240, 1 plus 0.023 divided by 12 to the power of 12 times -6. Okay, now this time I would expect the number to be smaller than this. Because remember, this is what I have now, and I want to know what would I have 6 years ago. So if the money's been growing, that means if I go backwards 6 years, the number should be smaller. Okay, I'm going to type that in real fast. And I come out with $6,307.59. So again, smaller because I'm going backwards in time. Okay, so what I would like you to try tonight is in your homework packet, again towards the back of your homework packet, I want you to find Lesson Master 7-4B. You also have a 7-4A in there, but I want you to find 7-4B. I think you can do, this whole assignment is not that bad. There's not that many problems. I think there's only maybe 10. And they're all just this formula. It's just this formula over and over and over again. So go ahead and work through this assignment tomorrow. I will be checking to see that you have it done, but we probably will not go over it yet tomorrow because I really want to focus on your quiz. So if you do have questions on it, make a note to yourself on what you had a question on, and we'll get to that sometime next week. So look for 7-4B in your homework packet. Plan to have that done tomorrow. And then make sure to check Blackboard for any other assignments that I'm leaving you for today.